So number 1 says make a table of at least 3 ordered pairs. So that's not a lot, right? Let's see. So what X values do you guys want to use for number 1?
-1, 2, -1.
You could use 1, 2, 3 or -1, 0, 1 or whatever.
We're doing 3. I lied.
Okay, 1 says y equals x minus 6. Whoops. That's not supposed to be on there. Okay, if I plug in -1 for x, what do I get? -1 minus 6?
-7.
Okay, that tells me that the graph is going to be really low. So if you want to conserve space, you might put your x-axis at the top.
Oh, that's nice.
That could help. You don't have to, but that's just an option. If I plug in 0 for x, what do I get?
-6.
If I plug in 1, -5. So I have -1, -7, 0, -6, and 1, -5. So it looks like that. Paxton, this is number 1. Almost done. I am done actually, but I'm waiting for you guys.
Home Depot thing, right? And we connected that because there's no.
Right.
Because we had to make that.
The domain is unlimited, so you connect it. I did take a point off on the test. I don't know if, I think if you didn't connect the dots.
Oh yeah, then that happened to me.
There were so many little parts to that test. A lot of it was just 1 point for each part.
Mm-hmm. Like the
Can't
did I miss it?
Except for like a few problems where were 3 or 4 points. Okay, anyways.
That was probably the only test that I could have gotten 100 on, and I messed it up.
Same. I got 98.
Okay, number 3, y equals -2x plus 5. Alright, what x values do you guys want to use? Same.
Same, man. Same.
What do you think the plus 5 would do to a graph?
Make it go up.
Up 5, kind of like the last chapter.
Mm.
We'll talk more about this stuff through as we go, but this chapter is all about the lines. If I plug in -1, -2 times -1
Dose.
plus 5.
7.
So this one's going to be pretty high. If you want to put your x-axis down low, that will save some room. I don't think you have to worry too much about room. 0, if I plug in 0, you get -2 times 0 is 0 plus 5. If I plug in 1, -2 times 1 is -2 plus 5.
-3.
So it's -1, 7, 0, 5, 1, 3. That wasn't very good.
I sure someone's like, no. No,
Better.
turn it down. Holy crap.
Wait, there's 8 graphs on the front, and there's 4, so there's 12 graphs overall actually. Number 5, y equals 4. This one's a weird one. We actually did something like this on the review. What does it mean if it just says y equals 4? That means the y value has to always be 4. The x value can be anything, but the y value has to be 4. So what does it look like if we graph negative 1, 4, 0, 4 and 1, 4? It looks like a horizontal line through 4 on the y-axis. So you guys kind of need to, it's kind of important to remember that. If it just says y equals like 4 or something, it's going to be a horizontal line through that on the y-axis.
Did the arrows gotta be that wide?
No. So number 6 says x equals -1. So guess what that means?
X is all -1.
All -1s for x. Y can be anything, but you have to use -1 for all the x's.
So, will we just use probably the same number, like if we did the other time?
Well, whatever at y's you put here doesn't really matter. What you're going to get if you do like -1, 1, or -1, 2, or -1, 3, you're just going to get a vertical line through -1 on the x-axis. So that's what x equals looks like. Okay, but I'm not going to give you time to do number 6. We're going to do number 7. Number 7, y equals 2/3 x minus 2. Okay. You can use whatever x values you want to, but there are a few x values that will not have a fraction in the answer. Now you can graph fractions. We did a few fraction graphs, but do you guys know what x values I could choose so there would be no fraction in the answer?
Like 3.
Yeah. You guys know what 2/3 of 3 is?
2.
2. If you, remember how that works? If you multiply, when you multiply by 2/3, you're really dividing by 3 and multiplying by 2. So if you choose a multiple of 3, it will reduce.
Oh, so like 9, 6, 3.
So 3 would work. What else do you think might work?
6, 9.
Okay, I don't want to graph 9 because that'd be off the charts.
Oh, sheesh.
6, what else? -3. What else?
9. 0.
0, right?
Oh yeah, because everything is a multiple of 0, because 0 times 0 is 0.
Yes. So, if we plug in 3, and we could have done -3, -6, it doesn't matter. If I plug in 3, 2/3 times 3 is 2 minus 2. Okay, if I plug in 6, do you guys know what 2/3 of 6 is?
4.
4. You can use a calculator or you can do this. 4 minus 2 is, if I plug in 0, what's 2/3 times 0?
0.
Minus 2? Okay, go away. So 3, 0, 6, 2, 0, negative 2. There's nothing wrong with getting fractions, by the way. That would have been okay. We could have just plugged in -1, 0, and 1 again. Okay, number 9. Oh, actually, no more graph for a while.
Wait, what did that one look like again? What did number 7 look like?
Just like
No
that.
graph.
Okay.
that what you got?
Mm-hmm.
Alright, number 9 says solve each linear equation for y. What does it mean to solve an equation for y?
Like, get y by itself?
Get y by itself. There's a reason we're doing this, but we'll kind of learn why next week.
Why?
Yeah.
Why?
That's fun, yes. Okay, so how do I get y by itself on the left side? Grant?
Divide 20 by 5x, or just by 5.
Okay, no. So the y is being added to 5x, or 5x is being added to
So
y.
you subtract.
So I have to subtract 5x.
I thought we had to like,
To get rid of a multiplied number, you divide. To get rid of an added value, you subtract.
I forgot how to do this.
Okay, so those are going to go away. Alright, does 20 minus 5x mix? So, okay, so you could write 20 minus 5x, but instead, I'm going to write it in the opposite order. I'm going to put minus 5x plus 20. And there is a reason we're doing that, but it's kind of a next week thing. I just want you guys to get in the habit of doing that. Putting the x in front. 20 minus 5x is the same thing as negative 5x plus 20. The order doesn't really matter. The negative matters and the positive matters, but the order doesn't really matter.
What?
Okay. Number 11 says...
Oh wait, that's it?
8x minus, yeah, once you get y by itself, you're done. 8x minus 2y equals 14. How do I get that y by itself? So normally, yeah. Normally when we're like solving for x, like if it's a one variable equation, what would we do in this case?
Add 8.
No? Subtract 8, right? Because this is a positive 8. This is the same thing as like 8 plus negative 2x. So to get rid of the 8, you have to subtract the 8. So on this one, and then we would divide by negative 2 second, right? Whoops.
Uh-oh.
We would subtract the 8 and then divide by negative 2. So that's kind of the same thing we're doing here to get y by itself. So we're going to subtract 8x to get rid of that value first. So that's going to go away. On the left side we will have negative 2y still. Negative 8x plus 14 on the right. Then how do I get rid of the negative 2? Divide. Here's the thing though, when you divide by negative 2, when you divide both sides by negative 2, every term has to be divided by negative 2. So it kind of looks like that. And then those canceled out, so we get y equals, what's negative 8 divided by negative 2?
4.
4x. What's 14 divided by negative 2? Negative 7, so minus 7. Now we've got y by itself, so that's the answer. Okay, 13 is a new section. It says write each linear equation in standard form. What is standard the weekend's tomorrow, okay.
Yo, my parents are gonna be home all weekend. They're gonna leave me home alone.
What?
Try not to burn it down.
Yeah, I'm gonna burn it down.
No, yeah, you should have a party.
I'm a party. I'm gonna go homeless, guys. Dad's gonna be burning it down.
Okay, so, guys, standard form is where you have the x's and then the y's, and then on the other side you have the constant. So it looks something like, this is an example of standard form. So it looks like ax plus by equals c, where a, b, and c are going to be some number. So it might look like this, it might look like 5y minus, or sorry, the x's are supposed to go first. 5x minus 10y equals 12. Something like this. This is standard form, or this. So how do I turn, what?
This is an interesting one of work.
Interesting. How do I turn this into standard form? Add the x to move it to the other side. Yeah, we've got a lot to learn this chapter.
Yeah.
It's kind of easier for pre-algebra because they've seen most of this, but
So is it XY?
it'll be all new for you guys. What's y plus x simplified to? Nothing. But also, I'm going to put it in standard form order, which means the x's should be in front. Okay, so it's going to be, instead of y plus x, x plus y equals 9.
Okay, this is gonna be the strangest section we've done all
Yeah,
year.
not 3.
The 3 has a defect.
Oh,
We should kill
poor
the
thing.
Liquor.
You should put it down like a dog.
three. We should release the 3.
It's a 3 and a 3.
Oh yeah, abort it. Oh man, abortion on that thing.
That's funny. She took a
She's
Sorry,
taking
man,
a
but you
test.
can't abort it after turning live.
Okay, 15. Okay. Before we do 15, I should probably make a small note really quickly. One thing about standard form is like making it neat. So you're not supposed to have any fractions. So do you guys remember, we've talked about this a long time ago. Do you remember how we got rid of a fraction?
You would mix them?
Multiply by 4 in this case. Because what happens when you multiply by 4, the 4 cancels out on that one. So you get like 4y equals 3x minus 20.
What? I don't remember.
No, the computer like messed up. What?
I don't remember.
We did it like chapter 2 or something, but we got rid of the fractions so to make the problem simpler by multiplying by the common denominator.
I remember this.
I literally don't remember.
Yeah, I don't either.
I remember this one surprisingly. I don't remember a lot of
Okay, anyways, to get rid of a fraction, you just multiply by the denominator basically. But you gotta multiply everything by that. So, you could do 4 times 3 is 12. 12 divided by 4 is 3, right? Or you could just cancel the 4's out right from the start. That's basically what happens. The 4's cancel out. But on these, you just have to multiply it. That's hopefully a reminder of what I know you guys forgot. Okay. 15 says y equals 4x minus 2 over 7. Okay, since the whole right side is divided by 7, how can I get rid of a divide by 7? Multiply by 7. Because what happens when we multiply by 7? That happens. They just go away. But the right side will still have a 7. So we got 7y equals 4x minus 2.
Is that
hold
7
on.
over 1 supposed to be there?
Yes.
And then you multiplied
I'm showing
the
that I'm
7
multiplying by 7 to get rid of divide by
and then you
7.
added the 7 times the y.
Okay, no. So, is this in standard form?
No, yes. Wait, it's not.
No. Standard form is like this, 3x plus 4y equals something. So the x's and the y's have to be on the left. So, how do I get this guy over to the other side? Subtract. Right, and he's supposed to go in front. So I'm not going to put 7y minus 4x.
Wait, did you call it a he?
Yes, I'm going to put negative 4x plus 7y equals negative 2.
It could be a she.
No.
Or they.
No, let's not get started on that.
I mean, in 2021, you could consider yourself a rat.
I created it, so I get to say
as
it's
a
a
rat.
I think we all do.
Wait, what?
Does that
You
mean
can
you're a rat?
call me a dog, okay?
What's
I'll
that
be
mean
part of
if
dog.
a guy considers
Bro.
themselves a she and his parent calls him or her? Does that mean it's in her?
Shut the heck up.
I'm so confused.
Because you're the owner of that.
Parents don't own their kids.
Alright.
You own that. But you just
Okay, so-
I made this.
are property?
they made the children.
Yes. God
So
made
you're
it.
talking about it. And then make her
Okay.
go down the toilet like a 20 minutes.
Alright, guys, listen. Okay, this is an acceptable answer. This is standard form. If you look this one up in the back though, it's gonna say this.
What?
What's the difference?
Oh,
They got all the negatives.
They didn't remove all the negatives. They multiplied both sides by negative 1.
Oh.
Okay, why did they do that? Because they think it looks neater when the front term is positive.
Can you
So-
stick to the top one?
But both these are the same. Yeah, you can stick with the top one.
Okay.
But when we grade this, that might cause us some confusion. These are both the correct answer. Okay, any questions? And,
Wait, hold. Wait. So.
I mean, if you want to, we could also like multiply everything by 2.
Let's
That would also be the same thing as all these.
let's just stick with.
Why would you do this?
Okay, I'm just saying, there's a lot of ways this could be written.
But why would you do that one? That one's so weird.
Guys, number 17. Got one more thing to learn still. Okay, number 17 says, find the x and y intercepts of each linear equation. Then use them to graph. Okay, so the question is, what is an x-intercept and what is a y-intercept? Have you guys heard those terms before?
What?
An x-intercept and a y-intercept?
Interception.
Okay, it's kind of like, not a football interception, it's more like when a plane is flying and a missile intercepts it.
What?
Terrorism is not.
More like war.
That's a very light terminology.
Okay. So, and a y-intercept is where the graph intercepts where it crosses the y-axis. So let's say I have a y-intercept there and an x-intercept there. The line would be like this. So the y-intercept is where the line intercepts, where the line hits the y-axis.
Like a missile.
And an x-intercept is where it intercepts the x-axis. Okay. What is the coordinates for this point?
0, 3.
0, 3. Okay, what's the coordinates for this point?
0,
What's the coordinates for this point?
0, 1.
What do you think we can say for sure is true about any y-intercept?
It's 0. So x is always 0.
The x value is always 0. So any y-intercept always has an x value of 0. What's the coordinates for this point?
0.
2, 0.
Zero.
How about this point?
1, 0.
This point?
0.
4, 0. So what can we say about an x-intercept?
Y is always 0.
The y value is always 0.
How is it always 0?
Because
when you're on the x-axis, you go over 2 and up 0. Or you go over 3 and up 0. So on the x-axis, the y value is always 0. Because you're not going, this number tells you how much you're going up and down, right? This number does. So if you're not going up and down, it's always going to be 0. Anyway, so back to 17. It said x minus 2y equals 4. This is not 17, I just made this up. This is nothing, actually.
Oh,
this is my
dang it, Mr. Jordan, you're hiding behind falsehood.
Okay, so if they don't draw a picture for me, how can I find the x-intercept or the y-intercept?
You do.
Do math. Math. You're
Jesus is
wrong.
on-
No, you do math.
Shh.
Get up.
Math is yeah. Well, yeah. It's so slow.
Yeah. I haven't messed up like that in a while. Okay, the y-intercept always happens when x is equal to 0. So we can find the y-intercept by making x into a 0. So if I put in 0 for x, and solve that for y, that will tell me the y-intercept.
what?
If I plug in 0 for x and solve this for y, that will give me the y-intercept.
So
Well, in this case, does 0 do anything on this? No. 0 minus 2y is just minus 2y, right? So if you have negative 2y equals 4, what's y going to have to be? Divide, so y is what? Negative 2. So when x is 0, y is negative 2. That's a y-intercept. That's on the y-axis.
So that's the answer for what?
And then you can do
We are going to
that.
graph this in a second. To find the x-intercept, I'm going to do the same thing, but put in a 0 for the y. If I make y 0, where can I put this? I'll put it down here. X minus 2 times 0 equals 4. What's 2 times 0?
0.
So x minus 0 equals 4.
So it's just x minus x.
What's x minus 0?
X.
X equals 4. So when y is 0, x has to be 4. That's the x-intercept. So all you do is you go on your graph and put a dot at 4, 0.
Hold on. What was all that stuff
This
yeah
or this.
yeah, and then all that down. What was that?
This is me figuring out. So I put in 0 for x and then figured out what y had to be. I solved this for y. I put in 0 for x and solved it for y. I rewrote this with a 0 where the x was. And I
Yeah.
solved it, figured out what
Okay,
the y was.
that's the only thing that we need to write down
No.
besides the graph.
This is the y-intercept and the x-intercept. I graph these two, I put the dots, 0, negative 2 right there, and then I just draw the line between those. Oh, it's the straightest line I've ever drawn. Oh, it's because the computer messed up.
Wait, so
Oh wait.
what's on the graph?
That is the graph of the lines.
Wait, but where did that?
Okay, guys, listen. Let me explain something. Each point on this line is made up of two coordinates, right? Has an x coordinate and y coordinate. For example, right there, it looks like 2, negative 1. But also there's all these little decimals and stuff, all the weird stuff in between there. But any point on this line has two coordinates. If I plug those coordinates in, it's a solution for this equation, like it works in this equation.
Ugh.
That's the relationship between this equation and this line. That's how graphs always work. any point on this graph is made up of an x and a y. If I knew what it was, I could plug it in right here and it would work in this equation. That's how these two are related. A graph is a picture to show you data quickly. Okay, maybe this represents like the height of a tree growing over time or something. But a graph just shows you a picture that gives you an idea of what's happening very quickly. This equation just describes the relationship between the x and the y. But anyway,
So is there, you said that there's 3 points on that, or just 2?
there's two.
Okay.
I just said it looks like it's going through 2, -1, so 2, -1 should be a solution for this also.
2 -1.
I said my line looks like it's going through 2, -1, which means 2, -1 should be,
Oh,
if I plugged it in, it should work up there.
okay.
Any point on this line has an x and a y that if I plugged it in right here would work. Okay. Well, that was painful. Let's try 19.
Well, that was painful.
19. It's really not that hard. It's just.
Well,
Because you went to the school for this.
yeah,
No.
you've been to college.
Yeah, I went to school for this when I was in 8th grade.
What?
That's true.
Wait,
School
eight.
lunch.
Wait, so 8th grade or 9th grade?
8th grade.
So you're smart as us.
I think he's a little
You're
smarter.
probably
Oh, he's a lot smarter.
Yeah.
That's
Okay.
for sure.
Well, yeah, when you get older,
At our age, he's
you guys will be smarter than you are now when you get older.
No, no.
Not smarter than you.
Not you're
Yeah, I don't think it's gonna be.
Well, there's different kinds of smarts also.
like dumb smart.
No,
That's
there's,
shit.
there's like
Yeah.
verbal,
How
reasoning,
am I?
musical, athletic,
I don't blame myself.
Sure, I'm
logical.
athletic. Sure, I'm athletic. So.
I want an A on because I'm like.
Okay. Social, that's another one.
I was
Social.
joking.
Okay, so we're going to repeat the process here. To find the y-intercept, I'm going to put in 0 for the x value.
So.
Like the
Listen, to find the y-intercept, I'm going to put in 0 for the x. Whatever comes out for y, that's going to be my y-intercept. So if I plug it in 0 right there, I get y equals -0 plus 4, which is just 0 plus 4. So what is 0 plus 4? 4. So when x is 0, y is 4. That's the y-intercept. Okay, how did I find the x-intercept a little bit ago?
You did
You
something.
make the y value to 0.
Yeah.
So on this time, I'm going to replace y with 0. So I'm going to put a 0 right there. 0 equals -x plus 4.
Okay. That's a big 0.
Okay, how do I solve that for x? Subtract 4. If
It does.
-x equals -4, divide by -1, x equals what? 4. So when y is 0, x is also 4. And then you just graph those two dots and draw a line.
So.
Computer being slow is not helping. Okay, 4, 0 is right there. Oh, come on now.
At the.
4, 0 is right there. And 0, 4 is right there.
Okay.
like where the line hits the like.
You don't do anything.
What do you mean?
We did it on.
Are you talking about like right here?
Yup, you weren't supposed to do that. I know, but I'm just saying. are you
Okay,
gonna do it?
there are an infinite number of points
Not gonna.
that work in there.
I get it.
You know how you like in between in the lines you like dotted the like one right there, you like put a
She's
dot right
being
there. That's what she's wondering. If you're
Yeah,
gonna-
He knows that.
I was just trying to explain that all the points on the line
Yeah.
are like this, which should work in this equation. Okay, I think we're good. No, I did not have to make up a dot last time. That was just me explaining.